Hello and welcome back here to the SOFiSTiK For You YouTube channel. Today I want to talk about the nonlinear temperature in beam elements. You can see this simple example I've picked to explain the workflow to you today. It's a single span box girder bridge, although the system actually doesn't really matter that much to explain the workflow, but we need to still have something in place. And you can also see two nonlinear vertical temperature profiles. And we will go through the definition of both of them in the next coming minutes. And we can start with the example definition. And I did it here in a graphical way in SOFi+ because I find it's the fastest way actually to set up these simple structures. So as I mentioned earlier, the system itself isn't really that important. Of course, you need to have a structural line or a beam element in your system, which we can use then to assign the nonlinear temperature profiles. There's one part in this workflow which is very essential, and this is we have to tweak the cross-section a little bit. So when we talk about this nonlinear vertical temperature profiles, then we can't use the standard cross-sections available here in SOFi+ or in SOFiSTiK in general. So you will have to create a user-defined cross-section. Creating a user-defined cross-section isn't that tricky at all. So I'm not going to explain that much how it works today. So I will just open actually the already defined cross-section to show you what needs to be done to get this workflow actually to work. We see here there's three cross-sections, and I will just use here the first one. Okay, here in the cross-section editor, we see the cross-section shape, and we see also this manhole in the middle of the cross-section. So this is the end diaphragm. So we also can see 7 blue points here in the cross-section. And these are the essential thing for the whole workflow. At every position at this point, you will assign in the second step the temperature value. So it's up to you to place those points in the correct position. Also, you have to keep in mind, if you want to have the assignment along for the whole superstructure, but you use different cross-sections along the superstructure, you need to ensure that those points are available in each of the single cross-sections. Another important detail, you have to remember the name of each of those points. And therefore, I recommend name it straight away after you created them. So let me double click on one of those points. Here you can see the name is T3. So I know afterwards that T3 is exactly in this position. You might also wonder why those blue points. Well, the blue points are actually the stress points. But you can also use geometry points, for instance, of the cross-section. You just click to one of those options here, geometry point or stress point, to create the reference point for your temperature assignment. Important, you need to remember the name. So it's not that important which one of the both you use, but the name is more important. Okay, that's enough here from the cross-section. So we're actually done here in SOFi+, and we can move on to SSD, to the SOFiSTiK Structural Desktop. Here on the left-hand side in the project navigation, I've created a section which includes all the tasks I want to show you today. The first task here, the temperature points, is the SOFiSTiK Result Viewer. I created this task to remember the numbers or the names I have used for the stress points in the cross-section editor. So I can double check this here as well. So let me close this again. Here in this task, and this is now the more interesting part, all the magic happens to set up your vertical temperature profiles. So the program module we use is SOFiLOAD. And I also use the echo command with the load extra option, which basically means to extend the output of the load definitions. This is for me that I can actually check my inputs afterwards in the report. In this particular workflow, I have used actually the option to assign the temperature on particular group numbers. In my example, I have created the whole superstructure comes with the group number 20. So it's just for me to save, I don't know, a little bit of time in entering the values using the variables rather than do it one by one. First and foremost, when it comes to a definition of these temperature loads, we have to create a load case. So I start here with the load case 1000 and I assign it to the type none. Then the next input line is already the beam command, and the beam command specifies the load on a beam. And in that particular case, I specify the loads, or in our case, the temperature, for beams of the group 20. The type is T for temperature. So now we have two inputs left, which are essential to create the profile of the nonlinear temperature. And the PA value now indicates the temperature value. Here we got 17.8, which is value on the very top of my cross section. And the next input is already the reference. So basically the reference point I want to use in my cross section, I use T1, which is the stress point at the very top of the cross section. So I do this input line for each of those single points I want to assign a temperature to. Here I got in total 7, of course. And basically that's it, how you can specify a nonlinear vertical temperature profile in the beam element. But there's one more thing you need to consider, and this is the command evaluate and the type of the evaluation. And therefore I will quickly open the user manual so you can find the description here as well. So this is the evaluate command, and as you can see, I have used here the option or the type TAIG to calculate the equivalent linear temperature load plus the eigenstress. And with that, the whole input is done. I also created the second vertical temperature profile, and I used a different input option here in CADIMP, just to give you an idea how you can actually optimize the text input in your projects. So instead of typing all single lines one by one, you can also use this tabular input. And for all values which should stay constant or won't change actually for the following input lines, can be placed at the very end of the input line. From equal GRP means that all from values for the following input lines will be considered as GRP. And then TO means basically the group number, and then the type is T. And at the very end, we use the evaluate command again. So let's calculate the task and double check the report. Okay, in the report we get of course a very long list. So every element in the group number 20 will receive now the temperature values we have specified in the SOFiLOAD module. And just quickly to show you how this output or what the output or the table includes, we have the number of the element. We see here the load value, basically our temperature, and we have again another load value input. Basically, we assign the value at the start and at the end of the beam element. And then last but not least, we see also some coordinate information where we have assigned this load value to. And here at the very end, we see this set E column, which shows you the ordinate in Z direction of this temperature assignment. So we got 0, 270, and so on and so forth. Okay, so this is the possibility how you can check the input values you have created. Now, we haven't calculated anything yet, so we don't have any results. Let me close this as well. So let's do that. Therefore, we can use the standard linear analysis task, so the graphical task, or if you use the text input more frequently, then simply use the ASE program module. So I will simply right-click here and click on Calculate Linear Analysis to perform the calculation of both the load cases. And let's look into the visualization. Both load cases show up straight away. We got load case 1000 and we got also load case 1001. And the deflection we see at the moment is due to the temperature. Unfortunately, there's no good way to double check your inputs graphically so far. You can, of course, give it a try and open SOFiSTiK graphics. However, here you will only see the maximum value of the temperature assignment. So remember, I've used 10.50 or 60 for the input for the load case 1001, and for load case 1000 I've used 17.8. But we can't see basically the distribution in a graphical way in the vertical direction of our cross section. To tackle actually this problem, I created a text script here by myself. So I will not go through this in detail, but just to tell you what it does, I pick the information, the assigned temperature I have used in the SOFiLOAD module. I read it out from the database and I create a graphic to basically show me the distribution in vertical direction in a nice picture in my report. So we'll just show you basically the report over here, because I've calculated already, if I believe. Yes, so basically this is the report. We see here I can select a beam element number. I see also the cross-section which is used for this beam element number, and then I see the load case, which was the first one. Then, of course, I got a table of the temperature assignment, basically similar information we had already seen in the report earlier. But in addition, I also give a graphical output, which is more interesting for me for quick checks of the assignment I have done. And those 4 graphics just show the temperature which I have entered, the constant part, the linear part, and also the delta T nonlinear in a set direction. With that, we are at the end of this video, and let me just quickly wrap up the essential points of this workflow. So remember, when we want to do this nonlinear vertical temperature profile, we have to tweak the cross-section in the first place. And by tweaking, I mean we have to add actually information. And this information are those cross-section points, which can be stress points or geometric points. So this is completely up to you what you prefer. Important, however, is to remember the point numbers. And in a second step, within the SOFiLOAD program module, so text-based, not graphically, you have to assign the actual temperature value to these particular points in the input. That's it actually for this video. I hope you enjoyed it. I hope you learned something new. And if you want to learn more about the text input and the basics and the fundamentals, you will find a link in the description to the text input in SOFiSTiK For You Fundamentals course, where you can learn the CAD language to create proper scripts for your projects. So thanks for watching, and I hope I can welcome you in one of the next videos again.